Hello class, welcome to our lesson today. This is a combination of sections 3, 4, and 5 of chapter 5. It deals with the other sum and difference formulas and then the double angles. All those things are on your paper dealing with identities. They're the bottom two groups. So you want to make sure that you're looking at that as we go through this lesson. And so you can see the formulas and how they are represented. Okay, the first question we're going to look at is just a verifying question. It's a pretty simple one, but it showcases the double angle idea. You want to start with the left side. So remember, whenever you take something squared, it's that thing times itself. You FOIL that out and distribute. And then sine squared plus cosine squared, that's just 1. And then the identity that we need to really start to look at is 2 sine theta or x, cosine theta or x. That's on your double angle formulas. It's the first one. That's sine of 2x. You have u's on your formula sheet or different variables. That's irrelevant. Okay, whatever the variable is would be consistent with any question. But 2 sine of x cosine of x is sine of 2x, and then plus 1. For the next one, I would start on the left side because it's hard to get something out of the right. Start on the right side because it's hard to get something out of the left side. So then the bottom here is secant squared because 1 plus tangent squared is my Pythagorean identity. Secant squared can go to the top and be cosine squared because they're reciprocals of one another. I change tangent into sine over cosine, do a little simplifying with the cosine squared and the cosine. One of those cosines go away. And then I have 2 sine x cosine x, and again, that's sine of 2x. So those are some things you want to keep in mind as you're looking at this scenario. Okay, the next scenario is something that we actually talked about in section 5.3. You're going to have to be able to take a situation and then draw it out in whatever quadrant it needs to be. So S is in quadrant 2, so this first triangle is with angle S. Cosine is negative 15 over 17. Pythagorean theorem would make this 8. Sine of t is 4 over 5, and then that means the adjacent is 3. So you're going to be using those two triangles. You might want to write those down for all the questions that we're dealing with on the next couple slides. And we use those to find what the different trig values, or ratios, with s and t. So for sine of s plus t, I just use my formula sheet. So you'll notice it says sine of s plus t is sine of s, cosine t plus cosine s sine t. I just find all those ratios from the triangles on the previous slide. I write them all in, combine like terms. The denominators of the two groups should be the same. And I combine that together and I get negative 36 over 85. Remember, sine is y over r, or opposite over hypotenuse. And then cosine would be the x over r, or adjacent over hypotenuse. The cosine of s plus t, make sure you're in the right order. Cosine of s plus t is cosine s, cosine t, minus sine of s times sine of t. And you'll use that to help answer the question for cosine of s plus t. Now the trouble is, on this scenario, when you do tangent of s plus t, if you look on your formula sheet, tangent of s plus t is very complicated. It has plus minus on the top, plus minus on the bottom. It's a lot of multiplication. If this is a systematic question where you already found sine and cosine, it would be faster to just say, oh, well, tangent is sine over cosine. And so you just take the sine answer you found and the cosine answer and divide them. And the denominators of 85 here will just cancel out. And you're left with just negative 36 over 77, which would be positive because negative divided by negative is positive. That's one option that could save you a little bit of time on questions like this. The quadrant that s plus t, the angle is in, is strictly based on all students take calculus or just figuring out where things are positive. So if you go back to the previous slide, sine was a negative, cosine was negative, and tangent was positive. So sine's negative, cosine's negative, tangent's positive. That would occur in quadrant 3. So some things to remember: making sure that your negative signs are in the right spot, making sure negative divided by negative is positive, and you can shortcut tangent a little bit if you've already found sine and cosine. Reiteration about cofunctions. Remember, they're complementary. So in this question here, I didn't tell you what the trig function was, but you see the angles add up to add up to 90, and cosecant and secant are cofunctions. This next one, tangent and cotangent, are cofunctions, so they add up to 90 degrees. Just add up the pieces, set it equal to 90, and solve for x, and that will give you the answer of x equals 14. There could be two styles of questions on that. One could be solve for x. The other could be figure out what the angles are, so you'd have to plug x back into the equations or the expressions for you to be able to find that answer. But remember, sine and cosine are cofunctions, secant, cosecant. Tangent, cotangent, that's why they're named the way they are, and their angles add up to 90 degrees. Okay, the next scenario, cosine is 4 over 5 and sine is less than 0. That would put me in quadrant 4 because cosine's positive and sine is negative. Adjacent is 4, hypotenuse is 5, opposite would be negative 3. Now we're using the double angle formula. So those are at the bottom of your page. Sine of 2 theta is 2 sine theta cosine theta. So I just find sine of theta, that's negative 3 over 5, and cosine is 4 over 5. Those two are flip-flop with how I wrote them. I just written it that way because I was starting with this 4 over 5, but realized the 4/5 corresponds to cosine, and then sine corresponds to the negative 3/5. And I get negative 24 over 25. If there's a root involved, you multiply the pieces with roots together, multiply the pieces without. It should still be rationalized as a final answer. For cosine of 2 theta, you have some options. I tend to pick the first one, which is cosine squared minus sine squared. Cosine squared is 4/5. I square it, I get 16/25 minus 9/25 because negative 3/5 squared. That will just give me 7 out of 25. Again, tangent of 2 theta, really complicated formula, a little bit less complicated than the addition one, okay, for some indifferences. But if you've already found sine and cosine, you might as well just divide it. And you take the sine number, which is negative 24 over 7, and that'll give you negative 24/7 as a final answer. All right, so just to recap, use the identity pages. Make sure you notice the pieces that should be subtracted or added. If you've already done sine and cosine, tangent should just be the ratio of those two divided out. And then for cosine of 2 theta, you get to pick which version you want to use. I would suggest using the cosine squared minus sine squared just because the fractions ends up working decently together. Have a good day, everyone.